Thank you for registering for our beginner's course for IT Basics, Networks, and AWS. To start with, I would like to quickly explain the scope of this course. There are two main goals for this course. We would like to make sure that you gain a solid foundation in the theory of practical IT, and then use this foundation to create your first cloud network. To start with, we will begin with an introduction into networks, describing in detail what they are and the related terms through our presentation lectures. From here, we will conduct our hands-on demonstrations using AWS. This is our main online cloud service tool. Together, we will create a virtual network and online server ourselves, so we can really experience this exciting technology. Let's get started. In this course, we will have a focus on classroom-style lectures. However, since we cannot gain a full understanding of all the skills with only visual lectures alone, we will be conducting hands-on demonstrations using AWS. Combining these two methods together, you will gain a much deeper understanding of the content. This course will provide hands-on learning using AWS, which is designed to give you an understanding of the servers and networks that we will be using in this course. These are practical demonstrations using AWS, the popular on-demand cloud computing platform owned by Amazon. However, some people may not want to try these practical AWS operations. If so, feel free to just watch the lecture videos alone. You can learn AWS operations on your own through our exercises, or you can simply watch them to get an idea of how they work. The choice is yours. In the case of engineers, however, or those aspiring to be engineers, we strongly recommend learning while trying the actual operations yourself. Here, I would like to cover the overall flow of this course, starting with network basics. In this lecture, we will explore the basic roles of networks and their interactions with the server. Network basics, IP addresses and URLs. In this lecture, let's learn the roles and relationships of IP addresses and URLs within the network. Subnet masks and subnet. In this lecture, let's understand what a subnet is and how to create a subnet in your own network using subnet masks. What is AWS? In this lecture, we will learn the range of cloud services provided by AWS. Build a network on AWS 1. In this lecture, we will look at VPCs, which are a virtual network tool using AWS. Build a network on AWS 2. In this lecture, we will create our own subnets using AWS's VPC, exploring the relationship between the subnet masks and the subnet. Build a server in VPC. In this lecture, we would like to build an EC2 instance, which will add a server onto our VPC. Access control. In this lecture, let's understand the functions of AWS that allow us to control network traffic. Configure network ACL. In this lecture, we will set up the network ACL to understand protocols and port numbers in VPC. Lastly, your next steps to build IT skills, which is our bonus lecture. Here, we will explore additional IT basic courses and pathways for you to gain more important skills in your IT journey. Let's start learning IT basics from the next lecture. Understanding a network. In this section, you will gain a basic understanding of a network. Network basics. In this lecture, you will learn the basic role of a network from the interaction with a server, Network Basics, IP address and URLs. In this lecture, you will learn the relationship and role of IP addresses and URLs in a network. Networks and the Internet. In this lecture, you will see how the network is deployed around the world as the Internet we use. Networks and the Internet. In this lecture, you will compare and verify the roles of IP addresses and MAC addresses in a network. Subnet and subnet masks. In this lecture, you will learn the settings needed to create a subnet in your network through subnet masking. Communication protocols and the OSI reference model. In this lecture, you will review the types of communication protocols and their role between layers in the OSI reference model. Build the network on AWS 1. In this lecture, you will learn about VPCs, which are virtual networks, using AWS. Building a network on AWS 2. Create a subnet using AWS VPC and learn the relationship between subnet masks and the subnet. Build a network on AWS 3. Set the security group of the EC2 instance to understand the protocol and port numbers in an actual server. Use Route 53 as a DNS server. In this lecture, you will register a domain with Route 53 and set the domain to an IP address. Network Basics. In this lecture, I would like to explain about the computer network that connects servers via the Internet. It is the network that enables the interaction between a client and a server. I'm sure most of you frequently access the Internet from PC or your smartphones, so I hope to explain a little bit more how this process works. What kind of network mechanism is required to deliver requests over the Internet? First of all, if you don't know the address of the server, you won't be able to send any requests to the server. It's very important that you know the destination. The destination of a server is the URL. You can view websites using the URL, and it is a typical Internet address. The destination of the server is called the URL. You can view websites using the URL, and it's a typical Internet address. The URL is the address to which the request will be delivered. The address to which your request is sent is the URL. But what about your PC or smartphone? You don't have a URL, so how do you get a response from the server? You don't have a URL, so how would you get a response from the server? Clients also need an address to receive a response from the server, and this comes in the form of an IP address. The IP address is used specifically for this purpose. Most Internet devices you have, like a smartphone or a PC, have an IP address, and this is used to direct the response. The IP address is the primary address for requests and responses. In fact, the URL is actually compatible with an IP address, and the URL is the one that converts the IP address into an easy-to-read format. The URL of Amazon.com has its own IP address associated with it. The address of the server to which the request is sent is also an IP address. When accessing a website, it can still be a good way to access through the IP address directly and send a request to the server. However, when you want to visit a website, you probably don't know the IP address, even though you may remember the URL. Actually, if you enter the IP address of the Amazon web page following the letters https:// you can access the web page all the same. In this way, rather than the URL, the IP address is the fundamental address. When I asked you to build a website with an EC2 instance in the previous lecture, you accessed it with an IP address for the instance. However, as you can imagine, the disadvantage of an IP address is that it's very difficult to remember because it's a simple collection of numbers. That is why we use URLs today. This basically creates a message saying that this IP address can be found at this URL. The order of the request which the client sends is also important. Let's think about it like this. If requests have been split and sent several times, in the example below, where you send the request, I buy 3 products, these messages may be separated into the following data, like I, products, 3, or buy. On the client side, even if you send the request in the correct order, it's possible that the order will be lost while being sent over the network. So, it's possible that it ends up becoming a request the server cannot understand. For this reason, it's important to determine a kind of rule so that the order can be reorganized at the point where it's received. This rule makes it possible to receive and organize the request messages in order. For example, the rule marks 01, 02, 03, 04 in the order in which they were sent, so they can be sorted in that order when they're received. By doing so, the client side can send a request and the server side can receive it correctly. Every day, we send many pieces of data to each other over the internet. We call one of these units of disjointed data a packet. This system is often referred to as packet communication, and it's a basic principle of the internet. Data transmission is carried out in parallel by dividing the transmission data into these units called packets. And the set of rules, such as the order of these transmissions, is called a protocol. By sending data in these disjointed forms, it's possible to send large amounts of data at high speed and in real time. This creative mechanism allows high-speed internet access. Communication convention for data is called a protocol. The protocol is shared around the world as procedures and standards for computer-to-computer communication. The protocol determines the method of address, the order in which the data is sent, the ID of the message, and so on. Only computers that understand the protocol are able to send and receive these messages. The communication protocol of a website is called HTTP. HTTP is an abbreviation for Hypertext Transfer Protocol. You've probably seen HTTP at the beginning of a URL, right? This is a declaration that the site will communicate using the protocol called HTTP. The website itself is created by a programming language called HTML, which stands for Hypertext Markup Language. And HTTP is a communication protocol for this HTML. With this current understanding of networks, IP addresses, and URLs completed, I'm now going to take a deeper look into IP addresses and URLs in a network. As mentioned before, the IP address is hard for people to read and remember. This is why we convert it to a URL, which is an easily readable address. To do this, there is a process of translation that needs to happen between the IP and the URL address. The IP address to URL translation is conducted at a server called a domain name system server. It's called DNS server for short. DNS server controls the relationship between the URL and the IP address to understand where the URL really is and tells everyone who uses the internet. DNS servers control the relationship between the URL and the IP addresses to understand where the URL really is located and tells people through the internet. When surfing the web using URLs, a DNS server will be required. There are DNS servers around the world that we use to identify the IP addresses associated with these URLs. This is how you're able to access some of these URLs, through a number of DNS servers. In this way, the client terminal, like a PC, also uses URLs and IP addresses to exchange requests and responses with the server. For example, when you type in Amazon.com, your PC then asks the DNS server, "Please tell me the IP address of this URL." The DNS server then tells your PC where the address is and the IP address that's associated with it. It is because the DNS has shared this information with you that you can now send a request to the server. Now, Because the DNS server has shared this information with you, you can send a request to Amazon servers. Let's check the relationship between the URL and the domain. Part of the URL is called the domain. You can see it here. This is the typical domain. The URL is configured by a domain. A domain is a string that provides an easy-to-understand IP address for which there is only one on the internet. It is defined in a hierarchical structure. For example, Amazon's website for Japan has a domain, amazon.co.jp. The last string of the domain, .jp, is called the top-level domain. You can see that the JP indicates Japan, so this site is a Japanese website. The second string from the right side, .co, is a second-level domain. CO indicates the corporation, and you can see that this is a website for a company. Amazon is a third-level domain. It is a domain that indicates the name of the site. By understanding the hierarchy of domains in this way, you can get some information about where and what kind of website it is. A host name is a domain name assigned to the host computer, and www is the host name in a typical URL. www is an abbreviation for World Wide Web, and is also used in the sense of the Internet. The hypertext system provided on the Internet is also called the World Wide Web. HTTP or HTTPS on the left is the protocol. HTTP and HTTPS are protocols that specify the site communication. HTTPS is a protocol that provides secure communication using encryption. It indicates that we will communicate with this HTTPS rule. Back on the right side, you'll see /blog/index. Actually, these strings are not considered a domain from here. The right side of the top-level domain shows the directory structure for this URL. After you've created a URL in one domain, it's common to divide the URL into pages. In this case, you'd separate the pages into directories with a slash. The directory shows the folder name and location on the server and represents the hierarchy of this URL. This example is a subdomain. The /blog part indicates it's a blog page. The last part, /index, is the file name. This is an index.html. The smallest unit of the URL is this file name. In this way, the URL is made by various elements within the domain. Because a domain is hierarchical in this way, you'll ask many DNS servers where to find each element in the domain. The root directory is the first DNS to which you'll ask the location of the website. For instance, you'll ask the location of .jp. The root directory then shares with you the DNSs which know that .jp is a Japanese site. The root directory then shares with you the DNSs which know .jp as a Japanese site. From there, you'll next ask where is .co. The DNS will tell you other DNS locations that are managing .co domains. If you were to ask .ne, you'll find the DNSs which manage .ne domains. Next, you would ask where Amazon is. Finally, you'll get a DNS that tells you amazon.co.jp. These DNS roles are called routing. Services and companies that provide the information of a domain and URL are called ISPs. ISP is an abbreviation for Internet Service Provider. Many of you will have signed a contract with an ISP when you set up your internet at home. Under the agreement, your ISP will give you access to a DNS server by providing you with a domain registration and IP address. This allows you to connect your PC or smartphone to the internet. There are ISPs all over the world who provide these domains and DNS servers. This is why we're able to access websites all over the world. There are three communication protocols for websites: HTTP, HTTPS, and FTP. HTTP is a basic protocol used to send and receive data between web servers and clients. HTTPS is an abbreviation for Hypertext Transfer Protocol Secure. It has a secure S and is a protocol for more secure HTTP communication. HTTPS uses SSL and other encryption methods to implement the secure communications. SSL is a common mechanism to encrypt HTTP communication. Currently, it's a standard to use websites with HTTPS instead of HTTP for security reasons. Next, FTP stands for File Transfer Protocol. It's a communication protocol for file transfer between a client and a web server on a computer network. We can use FTP to transfer files alone to the web server. We basically only use HTTP and HTTPS, so for now, it's okay if you only remember these two protocols. When you access a website, you use a software called a web browser. For example, Internet Explorer was one of the most well-known web browsers. Now, more people are using others like Google Chrome. Actually, Internet Explorer is an old browser and is not currently updated, so it's not our recommended browser to use. It was provided by Microsoft, but now Microsoft offers a new web browser called Edge. These web browsers communicate between HTTP and HTTPS and display website pages results. These web browsers communicate between HTTP and HTTPS and display website page results from the server to your PC. Now, let's explore how your web browser works. You can use Uniform Resource Identifier, or URI, to communicate with the server over HTTP and to retrieve content. URI is a rule that provides how to request an HTML document. You can use URI to communicate over HTTP. The web browser analyzes the HTML using URI and displays it as a website. In addition to HTML, there is XML. XML is an HTML companion, but it's a language for displaying structured documents. Based on the results of parsing, the web browser arranges characters and images appropriately, adjusts the size of characters, and adds colors. If your web browser and the web server work together, you'll be able to view the website. There are a series of operations done to display websites in a web browser. Subnet and subnet masks. In this lecture, you will learn about subnet roles and subnet masks and how they are configured. In the previous lecture, we talked about private networks. Now, I would like for us to consider how a private network is configured. Of course, it's a prerequisite that a network is configured when the physical network equipment is installed. So for example, if you install a Wi-Fi terminal in your house, you are now able to connect to a wireless network line. And this means you now have a network in your house. While it is necessary that you already have a network device, for now, let's simply explore how the network device determines the network range. First, you need to define the network range itself. It is necessary to determine the number of terminals connected to the Wi-Fi network line. So, if there are 5 terminals that can connect to the Wi-Fi network, the Wi-Fi terminal needs to be prepared to assign 5 private IP addresses. Determining the required IP address range is an important part of the overall network usage range, among other things like hardware. When we are talking about network range, this is the kind of situation we mean. The notation of this IP address range looks like this. For example, 10.0.1.0/16. Of course, this is just an example. there are various patterns in the numerical values that could be used. 10.0.1.0/16. The left side of this is the IP address, right? 10.0.1.0/16. The left side is the IP address, right? But what's this on the right, the 16? This /16 part is what we call the subnet mask. This combination of IP address and subnet mask determines the IP usage range and network range. This IP address /subnet combination pattern is always performed when configuring a standard network. A subnet is a subnetwork unit that we use to divide the network. We'll cover this in more detail throughout the lecture, and at this stage it may seem that the subnet mask is only used to create subnets within a network, but it can actually apply a subnet to the entire network as a whole, not just within the network. So for now, you should always use the subnet mask. For this reason, you should always use the subnet mask when determining the range of IP addresses for your network. Now let's try to visualize this. This is an example of an AWS network configuration. In another lecture, we will actually make this network configuration together. This VPC here refers to a virtual network. As you can see, the IP address range of this is 10.0.1.0/16. This indicates the network range of the VPC. A specific IP address is not set in the network itself, only the range of IP addresses like this is set. A specific IP address is not set in the network itself, only the range of available IP addresses like this is set. Keep in mind that a specific IP address is not set in the network itself, only the range of available IP addresses are set. In addition, public subnets and private subnets are set up, and we'll talk more about this later. These are the smallest unit that make up a network. Note that both of these subnets have subnet masking. Let's explore the IP address and subnet masks. The subnet mask determines the range of IP addresses that you can use in the network. It is necessary to confirm the relationship between subnets and the IP address. So let's take a closer look. First, the IP address. The numbers from 0 to 255 are used to make up the IPv4 IP address. Numbers from 0 to 255 are decimal. If this is displayed in binary form, it will be converted to 8 binary values. Of course, it's not necessary to know binary now. Just understand that it's a numeric pattern made with only 2 values, 0 and 1. For example, the decimal of 10 is converted into an 8-digit number, 00001010, in this decimal system. In other words, if the IP address 10.0.0.255 is expressed in binary rotation, it will be a 32-digit number. 0 is represented by 8 zeros, and 255 is represented by 8 ones. So just remember that within the IPv4 pattern, each decimal represents 8 binary numbers. A subnet mask is a number that is followed by an IP address. For instance, a /24, a /32, and so on. Since the IP address is a 32-digit binary number, the maximum subnet mask is 32. In the example here, /24 is the command that masks the number of 24 digits. We'll talk more about this in the next few slides. The range of IP addresses specified and masked in the subnet mask is called CIDR, or CIDR. CIDR stands for Classless Inter-Domain Routing. The method of setting up the subnet mask and adjusting the number of available IP addresses in the network range is called CIDR. What this means is specifying CIDR by subnet mask declares how many IP addresses are available in the subnet network. In this example, the subnet mask is 16, so the numerical value is fixed or locked from the leftmost 16 digits of the IP address. You can freely use the two 3-digit decimals from the right side of the IP address because there are remaining 16 digits. Remember that a full IPv4 IP address has up to 32 digits. A subnet of 16 will lock the first 2 decimals, leaving the last 2 adjustable. It's difficult, isn't it? Let's take a closer look. If the subnet mask is /8, it masks the range of 8 digits from the left in binary notation. Decimal 10 is displayed as 00001010 in binary notation, so a /8 masks this 8-digit binary. By masking, we mean it locks it into place. Since /16 masks 16 binary digits, the first 2 decimals of 10.0 will be masked and cannot be used. For the remaining 0.255, you can freely set the IP address range with anything from 0 to 255. When set to /24, 8 more digits will be masked. This means that only the rightmost 3 digits of the IP address can be controlled. In this case, you can create a subnet that has a total range of 256 IP addresses within the private network, keeping in mind that the final 3 digits could be anywhere from 0 to 255. If you mask with the subnet /16, you can set a valid IP address range within 0.0.255.255. Let's check the maximum and minimum IP address range. The minimum value of all decimals is 0. So an example IP address would be 0.0.0.0.0. And the maximum value of all is 255, like 255.255.255.255. In the example of a /16 subnet mask, the maximum and minimum IP address values are on the screen here. As you can see, you have the range of 0.0 or 255.255 and anywhere in between. When setting the network, it's important to determine the necessary IP address range based on the system used in the company and the number of terminals. It is also important to consider future expandability. /24 or /16 are often used when creating a subnet. With /16, you will have 65,534 addresses available, which gives you a fair amount of IP address range. This table shows the combination of IP addresses and subnets specified by the subnet mask. The larger the subnet, the smaller the range of IP addresses that can be used. This subnet makes it easier to find out where and what equipment is set up. Connecting a large number of terminals to a local network complicates the network. In this case, you can make it easier to understand by dividing your local network into several subnets. For example, if you have too many PCs like this, it's hard to find a particular terminal. If I want to look for a 10.0.0.234 terminal, it is very inefficient to look for it like this. For example, if I want to find 10.0.0.234 terminal, it is very inefficient to look for it like this. However, in a case like this, by dividing subnets, grouping them makes it easier to understand where and what roles the terminals that are located in the network play. When you split the local network into 3 networks, for example, the blue subnet, the green subnet, and the red subnet, then the 10.0.0.1 IP address will be grouped together in the 10.0.0 blue subnet. So communication to this IP address will be efficient. By making subnets, network management becomes much easier. As you can see from the diagram, each subnet is set by /24. By setting it with /24, you can lock the left 3 sets of digits with that group's identifying color. For example, blue equals 10.0.0, green equals 10.0.1, and red is 10.0.2. In this way, we only use the rightmost digit. In this way, we only use the rightmost 3-digit number to make the IP addresses. By setting up the subnet mask in this way, you can divide the network range and make it easier to find the right IP address. In network design, we will often create a network configuration in this way. Communication protocol. In this lecture, I would like to explain more detail about the communication protocol. Even if the IP address tells you the destination, you cannot communicate with them for a specific purpose if you don't know who you're sending it to. Because of this limitation, it's not possible to communicate effectively with the IP address alone. For this purpose, it is necessary to set up communications categorized by purpose when we use communication protocol. For example, the communication rule used would be different when sending an email using Outlook compared to displaying a website while browsing. Communication is carried out on a set of rules according to each purpose. Communication is carried out based on a set of rules according to each purpose. For example, if you have ever tried to set up an email, you may remember being forced to set up POP and SMTP. While you may not know what was actually being set up, many of these were set up according to this procedure. The outbound mail server is called SMTP server, and the inbound mail server is called a POP server. When setting up a mail address through a mailer, an application like Outlook, it is necessary to specify the IP address of both servers. SMTP and POP are protocols for mail communication. Simple Mail Transfer Protocol is the abbreviation for SMTP, and Post Office Protocol is the abbreviation for POP. These are the protocols for sending and receiving mail. In this way, we use dedicated protocols to send and receive emails. By setting up POP and SMTP in the mailer, you can send and receive mail using these protocols. In this way, each protocol is specified for various communications over the internet. There are rules for email and rules for the web. As covered in a previous lecture, HTTP is the communication protocol used to communicate with websites. In the same way, we use port numbers to determine where the data should be delivered to. A port is an endpoint for the operating system to communicate with data. When an OS, such as Windows, performs a data communication, the port number determines the receiving method. Multiple software running on the same computer specify the port number to establish communication. For example, Outlook needs a port number to receive email data. Let's take a look at a typical protocol and port number combination. HTTP communication uses port number 80. HTTPS uses port number 443. SSH uses number 22. SMTP for mail communications uses 25, and POP uses 110 and 143. Therefore, when using new software, we specify the port number on the server side for that communication. It's like a tag that will allow the right port to collect its relevant data. What is AWS? In this lecture, you will get an overview of AWS and how it works. AWS is a service that allows you to instantly use functions required for infrastructure development and application development, anytime, anywhere. AWS can be very useful. For example, in a situation where you need to use a server right away. Physical servers are sometimes called on-premise servers. These take a considerable amount of time to select, purchase, and install. However, if you were to use AWS, you could immediately get access to a virtual server called an EC2 on the internet. AWS has the ability to provide this EC2 server, so you can use it anytime on demand. In addition to servers, infrastructure like storage and databases can also be requested instantly on AWS. It's possible to use a storage that can store unlimited data using S3 within minutes. AWS also has a variety of database services like RDS and DynamoDB. You can use these to create the optimal database for each case. It is also a feature of AWS that this infrastructure can be instantly built on demand throughout various regions around the world. On-premise servers take a considerable amount of time to set up, and the initial cost is quite high at first. Some physical servers cost more than $10,000 each. However, on the cloud, you can easily use it for free at first, and it can be built within a few minutes. In the past, to maintain a system or infrastructure within a company, you had to physically install a server or database in either a data center or a server room, and set up the network infrastructure to support it. These time-consuming physical systems were needed to do what we can do now over the cloud in minutes. If you were to use AWS, you could configure a system that performs exactly the same services as a data center in no time at all. Once again, the greatest feature of AWS services is that you can create such a system anywhere in the world through the internet. Sets AWS apart from the other cloud providers is that you can create and use servers in the United States, Europe, Asia, and other areas instantly. While there are domestic cloud companies that you can use in most countries, these companies have a very limited range of deployment for their cloud services and are usually limited to their own individual countries. A virtual private cloud, or VPC, is a service that allows you to build a virtual network space within the AWS cloud. When using AWS, a specific kind of space on the cloud is required for the user to operate. The service that creates this space is VPC, Virtual Private Cloud. This allows you to build a virtual network space within the AWS cloud. VPC can set the network to be used in this cloud. This time, let's put the knowledge we've learned earlier into practice by actually setting up a network using VPC together. AWS account registration. We will now conduct a hands-on lecture with AWS to experience launching your own server. So if you would like to participate with us, follow this lecture and register your AWS account in advance. First, to begin with, Google the term AWS sign-in, and the AWS page should be the first option. Click here to go to the AWS page. This should take you to the AWS registration page. It should look something like this. In the upper right corner, there is a button called Start for Free, so please click here. When you click it, you'll be asked to enter the necessary information for registration. Enter your email, password, and account name, and then click Continue. Then, from here, you'll be directed to the Personal Information page. Make sure you click Personal Information button here, and then enter your name, phone number, address, zip code, and then click Continue at the bottom. You'll be then taken to the screen here. Please enter your credit card details. You'll be first asked to register your credit card even for a free account. This time we will be using a free tier of AWS, and by deleting the service before the deadline, even if you use the paid service, we'll be able to limit any costs. This is extremely helpful, especially while you're still at the beginner stage. With that in mind, please enter your credit card information here and click Verify and Add. Next, you'll be asked to verify your identity. You'll be authenticated using your mobile phone number, so enter it here and select voice or text message to execute. From here, you'll get a 4-digit verification code on your phone. This will be sent either by message or by voice. Enter the verification code here and click Verify Code. Next, you'll be taken to the different plan options. This time, just click Free. This will be all you need to complete the hands-on exercises with us during these lecture courses. The free account is more than enough to complete the hands-on exercises with us. Next, you'll be taken to the screen after registration. By receiving this completion email, it means the account registration has been fully completed. Now you can move on and sign into the console screen. So press the Sign into the console button, and you'll be able to log in to the AWS Management Console. Now you'll be asked to sign in with the account you've just created. Enter your email and password here, and then click Next. Finally, with that completed, you'll be on the screen to launch AWS services. This is called the AWS Management Console. And with this, your account registration is now complete. Building a network on AWS. In this lecture, I would like you to use AWS to learn how to build a network and experience setting up the IP address, port numbers, protocol, and subnets so that you can get a better understanding of the network in practice. Now that we have just learned about networks and subnet masks, here in this lecture, we will actually create a VPC and set the subnet configurations we've covered, setting the network range, called CIDR, and set the public subnet of our virtual network, which is called a VPC. To start with, we will introduce a service called VPC that we'll use in this lecture. As we said before, VPC stands for Virtual Private Cloud. VPC is a service used to build virtual networks in the cloud on AWS. The feature of VPC is that you can completely control the network environment by selecting the desired IP address range to build a virtual network, creating subnets, and setting the route tables and internet gateways. It is also possible to connect networks both inside and outside the cloud as needed. Multiple connection options are available, and you can connect externally via the internet. Multiple connection options are available, and you can connect externally through the internet. You could also connect your VPC using a VPN or a leased line. Let's learn how to set up a VPC. Here, we are building a single VPC. In this picture, you can see that the VPC is created for one AZ, or availability zone. This is the simplest VPC pattern. Subnets specify only one AZ, but VPCs can specify multiple AZs in the same region. As we covered before, an AZ is a data center cluster owned by AWS. We will divide the network area of the VPC using a mechanism called subnets. VPC is required to have at least one subnet. You can create multiple subnets and divide VPC into arbitrary subnets. You will set up your VPC using the next 4 steps. First, set the address range using the CIDR method. This is a method of determining the available range of IP addresses. Second, set up the subnet in AZ availability zone. Creating at least one subnet is mandatory. Next, set up the route to the internet. And finally, set up the traffic allowances for your VPC. It is always necessary to set up what kind of traffic is allowed. Let's quickly recap subnets again. A subnet is a segment of network divided by CIDR. Understand it as a segment of a VPC. As we mentioned before, there are 2 main types, public subnets and private subnet. The public subnet has a gateway called an internet gateway for traffic to route through the internet, and it is a range of networks that can connect to the internet. A private subnet is a subnet that has no internet gateway configured. This will be the range of networks that are not connected to the internet. Multiple subnets can be placed in a VPC, and it's common practice to configure multiple subnets using different public and private subnets. Setting CIDR for VPCs and subnets will specify the network range and number of available IP addresses. As we covered earlier, the types of subnets are separated by the presence or absence of internet gateway routing. Subnets are used to define the access range of the internet. Therefore, the only difference between a private subnet and a public subnet is whether a route to internet gateway is configured or not. Public subnets are used to install resources that require an internet connection. Private subnets, however, are used for resources that you want to isolate from the internet and increase security. Let's use what we know so far to design a VPC network range using different subnets that we create for both purposes. I would like you to fully experience the features of a network by building a virtual network together on AWS. First, launch the AWS Management Console. Search for VPC and go to the VPC console screen. Remember, VPC is short for Virtual Private Cloud. From here, you can create the virtual network area on the cloud. This time, click on the VPC in the left menu. From here, you will create your first VPC. You should have one VPC by default. Click Create VPC at the top left. Use the screen to create a VPC. First, you need to set the name of your VPC. I'd like you to use the name Test. Then, we decide the CIDR block for the VPC. In this configuration, you will specify the available range of IP addresses as we covered before. Here, set the VPC to the CIDR of 10.0.0/16 for this practice case. This CIDR is often used as the default CIDR on the cloud. Because 16 is used as a subnet mask, the 2 numbers on the right side of the IP address can be used, and the IP address range is from 0 to 255. It is standard practice to use a subnet mask on a network like our VPC. This is to control the size and make it easier to manage. If you enable IPv6, you could also set up the IPv6 IP address. However, today we wouldn't be using this. This time we'll only be using IP address v4. Set tenancy as the default. When enabled, it will use your hardware to launch an instance into your VPC. Originally, the cloud is characterized by sharing a physical server with others, but if you don't want to share it, you can occupy it, similar to leasing. It should be known that this setting adds cost, so let's leave it as default. Finally, click Create at the bottom. You have now just created a network on AWS. Click Your VPC and you'll see that a VPC called Test has been created. This VPC is not connected to the internet yet. What should you do to make the VPC connect to the internet? In the past, when you would have connected to the internet in your home, you would have brought a router and used this as the entrance to the internet. A VPC also needs to set up a router as a gateway for the internet. The Internet Gateway provides an entrance to the internet for your VPC. Click on the Internet Gateway in the left menu and click Create Internet Gateway. And you can see the creation screen for this. Let's create an Internet Gateway with the name Test. You have now successfully created an Internet Gateway. However, this Internet Gateway is detached. In other words, it's not set anywhere. So you can click this check mark and connect it to the VPC named Test. First, select Attach to VPC here. Select the VPC named Test and attach. The status of the Internet Gateway has changed to Attached. The VPC you created is now connected to the Internet Gateway and routed to the Internet. Next, the subnet. The subnet mask partitions the IP address ranges of the network and groups them. I divided my VPC into a subnet called Blue and a subnet called Red in the previous lecture. I would like you to reproduce the same here. Click on the subnet in the left menu. Let's create a blue subnet by clicking Create a Subnet above. Choose the VPC called Test, and then create a blue subnet. Think of the availability zone as a data center of AWS. When you specify AZ, so I would like you to use the availability zone A. Then, enter the CIDR block. Enter /24 as the subnet mask here. Since the subnet mask of /16 was set in the VPC, you can specify the subnet mask that falls within the range of the VPC in the subnet. In other words, you need to set a number greater than 16. If you type 16 here, you'll get an error. So you have to put a number greater than 16. The standard is /24. /24 will make CIDR with a 256 IP address availability. Click Create to build the subnet. As shown earlier, this will help us to manage the groups within the network. Let's create another subnet called Red. First, select the VPC named Test. So I would like you to use the availability zone A and then set this subnet to 10.0.1.0/24 as the CIDR. This means that the range will not overlap with blue. Note that the difference from the blue subnet is that the third number in the CIDR is 1. Blue's setting of this number was 0. If you set Red's third number to 0, it will overlap with the blue and you'll get an error. You can't use the same CIDR range. By setting it to 1, we have set another CIDR range so that it won't overlap. Let's click Create. Finally, let's create the green subnet. Choose the VPC name Test, and we will change the availability zone. Select AZ and C this time. Deploying subnets to multiple availability zones is a common technique in AWS. This is to maintain constant coverage in case of some issue that happens to one of the AZs. This is to maintain constant coverage in case of some issue on one of the AZs. Then, set the third number in the CIDR block to 2 and create a subnet. Click Create to create the green subnet. Next, we will set one subnet as a public subnet. Let's tick the box for the blue subnet and then we will confirm. Configure this subnet to allow internet access and set the blue subnet to the public subnet configuration. To do this, set the internet gateway to this subnet. When you go to the bottom of the screen, you'll see a route table. By setting up the internet gateway that you've just installed in the VPC into this route table, you can route the blue subnet to the internet gateway and access the internet from here. Check blue and click on the route. On top of that, click Edit Route. Add a route from this screen. Press the button Add Route and go to Target and then click Target. Specify the internet gateway we've just created. This time, you will set this subnet so that anyone can access it from the internet. Please set the IP address of all to 0. This setting creates a public subnet that allows internet access from all IP addresses. Please save it and then close. If you go back to the subnet and check blue, you'll see that the blue subnet is set to Internet Gateway, and now you have public subnet in your VPC. If you install a web server that needs internet access on this public subnet, you will now have internet access through the blue subnet. Let's install a server called an EC2 into the VPC we created earlier. As per usual, we deploy AWS services like servers inside the network space we create. I will not go into the detail here about servers, as they're covered thoroughly in a different course that we run. So if you want to learn about servers from scratch, please refer to that course. To get started, search for EC2 on this search screen and press Enter. This is the screen for EC2, which will start the server on AWS. Simply click Launch Instance for now. This is the screen to start the server here. The first step is to select the Amazon Machine Image, or AMI. This is an image of the OS, or operating system. I'm sure everyone here knows that they're using an OS like Windows or Mac for their computer. In the same way, there is an OS for the server. Windows also has a server OS, but I think Linux might be even more widely known as a server OS. For now, select Linux from the top of the list. This is an instance that can be used for free, so it's perfect for this kind of introductory course. If you want to check what's available for free, check the Free tier button, and the free items will be listed. The top option is free from the beginning, so please select this one. Next, we come to a screen where we can select the instance type. Virtual servers are created in units called instances. In other words, this is where you're selecting the type of virtual server you want. Here is where you would decide the server performance, such as CPU and memory, depending on your operation. Just like when you buy a computer, you would likely check the performance of the CPU and so on. In the same way, we choose the number of CPUs and memory on your server. Select the first free instance type, T2 Micro, and click Next. This is more than enough for our purposes today. On this screen, set the location where you want your server to be installed. Here, you can select the VPC we've just created. If you click the VPC section, the VPC called Test will be displayed. By selecting this, you're able to set up the server on the network you created earlier. Now let's select one subnet. I'll choose the blue subnet, and this means the EC2 instance will be installed in data centers called an availability zone, which is where the subnet is located. There are various other settings that are not relevant right now, so for now, I'd like to complete this and just start the server on the VPC and proceed. We cover these additional settings in detail with our server course. From here, click Next. This screen is where we add the storage. In other words, the hard disk that will be used to store the data that's used by the server. I will be using the default storage, so we can just click Next. Here you can add tags. You can select the name, for example, as additional information that might help for complicated operations. This time, however, I'll proceed without adding any. Click Next again. Now we will set up the security group on this screen. A security group is a function that controls access to the network. You will learn about access control in our next lecture. We use the security group or network ACL to control access. Here we get to set which protocol is allowed to access our server. By default, communication with a protocol called SSH is allowed. This time, because we want to open a web page, we will need to add a setting for that too. You need the HTTP protocol to be allowed access. You're probably familiar with this protocol type in your daily use. Click Add a Rule to add HTTP. This will allow a website to be retrieved from the server. This means that the HTTP communication will be permitted by the traffic control of the security group. We'll talk more about this access control in the next lecture. For now, just click Review and Launch. This is the screen to check the settings and start the instance. Please go to the bottom and click Launch. This will open a screen for creating what is called a key pair. I already have an existing pair from before, but since this is your first time creating one, please select Create New Key Pair. Let's create a key pair called Udemy Test. These are used to authenticate the ownership when trying to use the server. In short, it's the key to access this server. From here, click Download Key Pair. The encryption key should have been downloaded, and you can now use this key to access the server you created. Click Launch at the end. Your server is now created. You can check the startup status by clicking the launch log. If you click the number on the left, the instances that are up and running will be displayed in a list. It's usually pretty fast, but because my instance is already running, it might take a little longer for yours than this. Using the cloud in this way, you can set up a virtual server in only a few minutes. Congratulations on successfully creating your very first server. Access control. In this lecture, we will learn the mechanism for implementing network communication control and access control. When you build a network, you create the rules that allow or deny specific communication to that network. For example, if just anyone can access your Wi-Fi at home, It's incredibly unsafe, isn't it? In the same way, it's necessary to control who accesses the network you've set up in the cloud. In this context, communication on the network is called traffic. Controlling this traffic is important, and it's your overall communication setting that does that job. I explained earlier that communication is made using protocol. This means that you can use these protocols to control the network traffic or network communication. AWS network traffic control is done through security groups and network ACLs. Security groups control communication traffic to your EC2 instances, and network ACLs control the communication traffic for subnets in your VPC. In this lecture, we will mainly be working with network ACLs set in the VPC. For example, if HTTP traffic is not allowed, you'll not be able to view web pages. When you browse a website, you will see HTTP or HTTPS written in the URL. If this HTTP or HTTPS communication is not permitted, you will not be able to access the website from the web server. In this example, the network ACL is set to only allow SSH on port 22. So even if you create a homepage, for example, you cannot access it. In this way, it's an important tool we use to control traffic, deciding the protocol and IP addresses. Doing this allows access only to that which fits the purpose of our network. In the next lecture, we will go back to the VPC operations screen and check how to control the VPC network. In this lecture, we will set up a network ACL. This will help us to understand the protocol and port numbers used in VPCs, and also to see how they're used on the internet in general. Now, let's actually set up the network ACL. First, open the VPC Management Console. We will proceed using this console screen here. If you look at the menu on the left, you can see the various functions of the VPC. First, click on the Network ACL in the Security section at the bottom. When we had built the VPC earlier, the Network ACL was created automatically. One Network ACL is created for each VPC, and as we have two VPCs here, the default VPC and the VPC named Test, we also have two different Network ACLs that have been created. Let's check out the Network ACL for the test VPC we made earlier. If you check it, the contents of the Network ACL will be displayed below. By setting these inbound and outbound rules, you can control inbound and outbound communications. Inbound rules are settings for communication that accesses your VPC subnet from outside, and outbound rules control the traffic headed out from your VPC subnet. Rule number 100, which you can find here in the inbound rule menu, allows all traffic to access all IP addresses. The network ACL is set to allow all communication like this by default. While there is a deny setting there set on the second line, it's not working because the rule number is not assigned. Now let's check what the outbound rules are. The outbound rules also allow all traffic to all IP addresses. Again, all network traffic is set to communicate by default. We will try editing the inbound rule here. Click Edit Inbound Rule. Here you can add or remove rules. First, click Add Rule. Then set the rule number. Let's set it to 101. The rules of the network ACLs are set in ascending order. Now let's set the protocol to allow communication. This time, for our purposes, select HTTP. This will allow us to display web pages. Because all traffic was allowed from the very first line, HTTP was already allowed, even if you didn't choose it. But today is just a trial, so let's practice by adding it now. Conversely, you can also set it to deny only HTTP by selecting Deny. But since the rule with the smaller number has priority, the deny rule would not be utilized if it was set as 101. But for now, let's just return it to allow and click Save. We can also set the outbound rules. First, click Add Rule, just like before, and let's set the number to 101 and allow HTTP communication. Let's quickly save these settings. In the network ACL, you can make settings such as permitting or denying communications for each protocol in this way. If you specify an IP address, you can set it to allow or deny communication from this specific address too. Doing this improves network security, controlling communication by using network ACLs. This will conclude our network ACL lecture. Further steps to gain more IT knowledge. Bonus lecture. In this lecture, I would like to showcase additional IT courses that you can use to gain deeper IT understanding. In this course, you've learned the foundational knowledge of networks and how they function. This is one important feature of what is called IT infrastructure. In saying that, there are many different areas of IT infrastructure to learn. Knowledge of servers, databases, the cloud, for example, are also essential for even a general understanding of IT infrastructure. Moreover, IT infrastructure alone is not enough for you to comprehensively understand IT as a whole. In addition to IT infrastructure, there are many more exciting areas to explore, like IT technology fundamentals, application development, and an understanding of IT as a human resource, or how it fits into real-world companies. These are also required to reach your goals as an IT professional. For this reason, we have prepared an additional course that will help you to easily build practical IT skills, similar to this course. The Beginner's Course for IT and AWS will comprehensively explain the foundational IT knowledge that you will need to enter this cutting-edge industry. As with this course, you will gain knowledge and experience by conducting both hands-on and classroom lectures. Because we can't understand all the skills through classroom lectures alone, we conduct hands-on practice using AWS to build your ability in even more IT tools. Combining these two practice methods, you will rapidly become a confident and experienced IT practitioner. Let's explore the course content. Understanding IT. In this lecture, you will understand what IT really means and its uses with common examples. Understanding a server. In this lecture, you will learn about IT equipment and the related software called servers that provide web services. We will include a hands-on server launch through AWS. Understanding a network. In this lecture, you will learn about networks that provide access to web services. We will include a hands-on network setting demonstration on AWS. Understanding a database. In this lecture, you will learn about databases that perform data processing for web services. We will include a hands-on database launch demonstration on AWS. Understanding virtualization and the cloud. In this lecture, learn about virtualization, a fundamental technology for implementing the cloud. Understand the cloud and all its features. Understanding web application development. In this lecture, come to understand development languages and the development environment required for web application development, SOR and SOE development, and IT human resource requirements. In this lecture, learn the development process for both SOR and SOE type teams and review their talent types, both from engineer and from business-focused perspectives. Take the first step towards becoming an IT specialist and start your IT journey the right way.